class. Welcome back to another lesson. Today's learning goal is I can add and subtract using scientific notation. So, the top of your notes should look something like this. Okay? And it should also say we can only add and subtract numbers if they have the same exponent. Otherwise, the place values do not line up. And it should have something that says proof right here. Okay. However, we're not going to do this proof right now. We're going to do that in class together. So you can hold off. We're going to hold off onto this section of the notes and complete that later. And today in class, or on this video, we're going to be doing questions 1 through 4 together, and then we will do the rest of those questions in class together as well. So, like it says, we can only add and subtract numbers if they have the same exponent. Otherwise, the place values don't line up, and we'll talk about what that means in class. A popular social networking site has the most members between ages 15 and 28. Within this age group, there are 5.11 times 10 to the 7th student members, and 9.55 times 10 to the 10 to the 7th non-student members. What is the total number of members in this age group? So here, we need to combine these two numbers, the number of number of students in this age group, which is 5.11 times 10 to the 7th, with the non-students, 9.55 times 10 to the 7th. And here they have the same exponent. So what we can simply do is add these two together. Line up our decimals. So we got 5.11 times 10 to the 7th. Times 10 to the 7th, plus 9.55 times 10 to the 7th. Now here, we're just going to simply add like we always do. So 1 plus 5 is 6, 6, 5 plus 9 is 14, times 10, and we're going to keep our same exponent. We do not add the exponent because, we'll talk about what that is later, but we just keep the same exponent. But here, we have something unique. We have this 4 right here, 14 actually. And as we know that this is not written in scientific notation because our coefficient, this number right here, okay, is greater than 10, or 10 or greater. So what we need to do is then change this into scientific notation. So we're going to make our coefficient smaller by a factor of 10, which means we're going to bump this up by a factor of 10. So that makes our final answer 1.446 times 10 to the 8th members, because we bumped the 7 up to an 8 because we made this coefficient smaller. Here, as of the 2010 census, the population of Wyoming was approximately 5.63 times 10 to the 5th. The population of Vermont was approximately 6.25 times 10 to the 5th. Find the total population of the two states. Total population, that means this is an addition problem. And look at that, we have the same exponent. That means we can just simply add our coefficients together. So we have 5.63 times 10 to the 5th and 6.25 times 10 to the 5th. Adding our two populations together. We're going to add vertically and keep the base 10. So we got, keep our exponent in the base 10. So we got the 8. 6 plus 2 is 8. 5 plus 6 is 11. 11.88 times 10 to the 5th, people. However, this is not in scientific notation, so that means we need to make our coefficient smaller by a factor of 10 and make our exponent greater. So we got 1.188 times 10 to the 6th people, which, as we will see, is our correct answer. Okay? Part B, it says find the difference between these two states. Now, in order to find the difference, we are going to still be able to do this because they have the same exponent. However, we need to figure out which one is larger. Vermont has the larger coefficient, and they have the same exponent, so therefore we are going to subtract 6.25 by 5.63. So we're going to do 6.25 times 10 to the 5th, subtract 5.63 times 10 to the 5th. all together. We're going to do subtraction. 5 minus 3 is 2. I'm going to have to borrow. That makes it 12 over here. 12 minus 6 is 6. We get 0.62 times 10 to the fifth. Now, again, this is not in scientific notation because of this coefficient. It is too small. It is less than 1. So, therefore, we're going to make this bigger, and then, therefore, we're going to make this exponent smaller. So, 6.2 times 10 to the fourth people, which is our final answer. Here, the approximate thickness of a standard CD is 1.2 times 10 to the negative third meter, and a slim CD case is about 5.4 times 10 to the negative 3. If the CD is placed on top of the CD case, what is the total thickness of the CD in the CD case? This, because we're finding the total thickness after placed on top of one another, means we're going to be adding the two thicknesses together. Here we have the same exponent, so we are already good to go. We got 1.2 times 10 to the negative third plus 5.4 times 10 to the negative third. We're going to add our coefficients. We got 6.6, keep our base 10 exponent, and this is in scientific notation, so we got 6.6 times 10 to the negative 3 meters. How much thicker is the CD case than the CD, which means that we're going to be subtracting. The slim CD case is bigger, so we're going to be subtracting 5.4 by 1.2. So 5.4 times 10 to the negative third, subtract 1.2 times 10 to the negative third. What we get is 4.2 times 10 to the negative third meters. 4.2 times 10 to the negative third meters. This is in scientific notation, so we don't have to do anything. At the end of one summer, there is about 1.5 times 10 to the 7th square kilometers of ice in the Arctic Ocean. By the end of the summer, how much of the ice has melted? Much of the ice has melted, and there are only 7 times 10 to the 6th square meters of ice. How much ice has melted? So this is the change in the ice from this amount to this amount. And so therefore this is going to be a subtraction problem because we're going to figure out how much ice is melted. That means how we're going to find the difference between the two. Now, notice here that this is a 7 and this is a 6. Uh-oh, that's going to be an issue. So what we need to do is make them the same exponent. Okay, when there are different exponents, we cannot subtract them, and we'll talk about why later on. So what we need to do is make them the same exponent. So what I'm going to do here is I am going to take this exponent, and I'm going to take this one. I'm going to take this exponent and make it bigger by 1 to match the 7. Okay, over here. Now, in order to do that, though, by the rule, we need to make this coefficient smaller by 10. So we're going to move the decimal place over this way. So we got 0.7 times 10 to the 7th. This is going to be the same number as this, just written differently, and therefore we can subtract. So we got 1.5 times 10 to the 7th, subtracted by 0.7 times 10 to the 7th. We get 0.8 times 10 to the 7th. And again, this is not in scientific notation right here because of this 0.8 coefficient. It's too small, so we're going to make it bigger and then make this smaller. So what we get is 8 times 10 to the 7th. Or 8 times 10 to the 7th. Excuse me, 6th, because we made it smaller. That's my bad. To the 6th, because we made it smaller. Square kilometers. Remember to use units. Let's go ahead and try number 5, actually, because we can use a little bit more practice with the questions that do not have the same exponent. So here, the approximate area of the Pacific Ocean is 6.4 times 10 to the 7th square miles. The area of the Arctic Ocean is about 5.4 times 10 to the 6th square miles. Find the approximate sum of the areas of the two oceans. So here we are adding them together, but here again, different exponents. So what I'm going to do is make this one bigger and make this one smaller. It doesn't really matter. I could make this smaller and this bigger as well to make the matching exponent be 6. So it doesn't really matter, but I'm going to choose the smaller one to make it bigger. Smaller exponent and make it bigger. You can do either way. You'll get the same answer. So we get 6.4 times 10 to the 7th. This new number becomes 0.54 times 10 to the 7th. So plus 0.54 times 10 to the 7th. Let's make this so that these exponents line up so that we don't get confused about things. 6.4 times 10 to the 7th. 0.54 times 10 to the 7th. And what we get is 6.94 times 10 to the 7th square miles. This is in scientific notation right here, so we don't have to change a thing. Go ahead and try this question out on your own. So here again, we're going to be doing the same thing, except here it says how much larger is the Pacific Ocean than the Arctic Ocean, which means we're subtracting. So we are going to, again, this was going to be 0.54 times 10 to the 7th. So therefore, we're doing 6.40. I'm going to put that O in there for placeholder, times 10 to the 7th, minus 0.54 times 10 to the 7th. We're going to have to borrow here, so this becomes a 3, this becomes a 10. 10 minus 4 is 6. Oh, excuse me. Borrow again. 13 minus 5 is 8. So we get 5.86 times 10 to the 7th square miles. I'm going to write that 7 a little bit better. So there you go. Again, we'll continue practicing with this later on. Oops, I don't know what happened there. Here we go, to the 7th. So yeah, hopefully you guys got a little practice with that, and we will continue working on that when we get to class.